Hi, my name is Rohit. I'm here to talk to you about the sport of curling. First, let's talk about how curling is played. Curling is a sport in which players slide stones on a sheet of ice towards a target area. There are two teams with four players in each team. One teammate slides the stone and two other teammates sweep its path so that the other stone can reach its target without friction coming in the way. The point is given to the team whose stone is the closest to the center target. Physical and social advantages. A good level of general fitness is an advantage in curling as each game lasts approximately 2 hours. It also provides great social interaction, builds teamwork, builds character, provides great exercise, and is relatively inexpensive. Now let's move on to the big question. How does a curling stone curl on ice? Well, curling is the only sport where the trajectory of the projectile can be influenced after release. Players sweep the ice directly in front of the curling stone to decrease the friction of the stone with the ice. This in turn affects the degree of curl on the stone as it slides down the length of the rink towards the target area. The heavy mass of the stone is what enables it to slide down the length of the rink without slowing down. Now let's delve deep into the physics behind curling. As you all know, g is the acceleration due to gravity, which is equal to 9.8 meters per second squared on Earth. G is the center of mass of the curling stone. Also, a granite curling stone weighs 20 kg. Nf is the resultant normal force exerted on the bottom of the curling stone due to contact with the ice. The coefficient of friction on ice is around 0.04, which also depends on the temperature. Friction is acting in the opposite direction of the motion of the stone. This friction force is due to the contact with the ice, and acts to slow down the stone as it slides down the ice. Since the curling stone is in rotational equilibrium, the sum of the Fn and Fg must equal to 0. This means that the normal force must exert a movement in the opposite direction to the movement caused by the friction. Now that we know a bit about why a curling stone curls on ice, we can apply this knowledge to this problem. So, Bill slides a 20 kg curling stone with the initial velocity of 1 meter per second on ice with an applied force of 16 newtons to the right. The coefficient of kinetic friction is 0.04. The goal is to reach the center target, which is 6.4 meters away from the initial launch position. How close to the target will the stone stop? Now we need to find out the solution of this problem, but first we need to make a free body diagram. As we already know, the mass of the stone is 20 kg. We can find out the Fg, which is 196 newtons, and thus find the Fn, which is also 196 newtons. To find the frictional force, we need to use the equation Ff equals mu Fn. As we know, the coefficient of friction is 0.04 and the normal force is 196, we can find out that the Ff is 7.84 newtons. To find the Fnet, we subtract the applied force of 16 newtons from the frictional force of 7.84 newtons to get the Fnet of 8.16 newtons. To find the acceleration of the stone, we need to use the equation Fnet equals ma, as Fnet is 8.16 newtons and the mass of the stone is 20 kg. We can rearrange for a to find the acceleration of negative 0.4 meters per second squared. It is negative because the stone is decelerating. To find out the distance of this stone, we need to use the equation v squared equals vi squared plus 2ad. We sub in the numbers as v is 0, vi is 1, and a is negative 0.4. We find out that the distance is 1.25 meters. Thus, we can say that the stone fails to reach its target as it is 5.15 meters away. These are the sources from which research was collected. This concludes the video, as I hope you all learned more about the sport of curling.